In this section, we are going to consider simple linear regression, specifically focusing on creating a scatter plot and looking at correlation and the coefficient of determination. These three things are essential whenever you consider the idea that two things might be associated or related. Now, in order to run this, there are some words that I just used that are vital to making sure you have an understanding of what is happening. And so I want to write out the definitions just so that we have, or at least the words, so we know what it is that we're talking about. The major pieces that we're going to want to focus on, the first is called a scatter plot. All right. And so when we talk about a scatter plot is typically a visual that is useful to help determine if there is an association between two quantitative variables. So when we're talking in statistics, we're constantly considering the type of variables that we're focusing on. One of the pieces that we're generally focusing on, kind of at a constant, is quantitative and qualitative variables. But the quantitative are ones that we are more apt to be able to analyze using numbers and definitions. And so when we have data that are both, we have two sets of data or two specific variables that are quantitative in nature, and we believe that the two of them have a relationship, that it's possible that there's a cause and effect relationship, then we want to take a scatter plot to see if that relationship actually exists. In this case, we're looking at a company who has, I have two variables. We'll notice that while I have a header for each, they are quantitative variables. The first one is the advertising budget for a specific company. It's in hundreds of dollars, so 41 would be $4,100 in advertising. 51 would be $5,100 in advertising. The second variable we're given is their sales in the same time period as the advertising budget. And so when the $4,100 was spent to advertise, the sales, or the return of sales for that company, was $144,000 in that time period. In the next one, $5,100 in sales yielded $151,000 in sales. I'm sorry, $5,100 in advertising yielded $151,000 in sales. And so the question becomes, is there a direct relationship between advertising and sales, or do they each fluctuate separately with no actual pattern? If there is a pattern, can we use the advertising budget to come up with a prediction of what the sales in? Hence, is there a cause and effect relationship that we might be able to use in order to establish an understanding of what could happen when one changes and the other one changes? And so when we think there is an association is the idea that a relationship may exist between two variables. And the relationship we're especially pick one, interested in is a cause and effect relationship. Now, I don't know that I can prove that it's a cause and effect, but I can study it and see if over time there's a pattern that would suggest that changing advertising does affect sales, or that changing sales does affect advertising. When we do this, we're going to have a couple of variables. We're going to have an X when we think there is a relationship. So if a relationship were to exist, that relationship would consist of two variables. The X variable, which is known as the independent variable, and the Y variable, which is known as the dependent variable. And the way I like to remember it is that Y depends on X. If we use that as a sentence, does advertising depend on sales, or does sales depend on advertising? And if we believe that sales depends on advertising, that would give us the idea that sales is our Y variable, or our dependent variable, and that advertising is our X variable. And sometimes we can't tell at all what the relationship's going to be. Okay. Now, the very first thing that we want to talk about is a scatter plot. In order to make a scatter plot, that's a visual that helps us to determine this association, we want to make sure that the X variable is in the first column and the Y variable is in the second column. Otherwise, it's going to be hard to make that associative relationship, or more importantly, that cause and effect. Once we have the x variable in one column and the y variable in a second, and they are directly next to each other, we can highlight the data. So we highlight our x and y variables. We go to Insert, and we click the scatter plot image, which is the little dots here, to insert a scatter plot or a bubble chart. And then we click the scatter plot here. Now, first of all, their axes are horrible because we don't have any sales lower than $2,500. And we don't have any, I'm sorry, sales lower than 120,000, and we don't have any advertising lower than 25. So what I would do first is I would probably fix my axes. So I'd format my axes to make sense, where my x, well, in this case, my y variable maybe goes from 120. And then I would probably fix my x-axis here, and maybe have my minimum be 25. So now we get a better view of the scatter plot, because our scatter plot is now in the same range as the data. When we look at a scatter plot, we want to determine an association. The question is whether a line, because we're doing simple linear regression, whether a line, because the linear has the word line in it, would fit through this data reasonably, implying that association. And so we're looking at this data set, and we're trying to say, is there a line that I could draw through here, maybe that would go through many of the points and actually show that an association exists. Now, if you want to draw the line on here to see what it might look like, what you would pick is any blue point on here. Let me make the scatter plot one more time really quickly. So I would highlight my data. I would click Insert, this little chart right here, and Scatter. I don't like my axes, so I would take my y-axes and I would format them. My lowest seems to be at about 120. I would take my x-axis. You can see 30, just like below 30, doesn't really have that much, so I'd probably choose about 25. So now I have a more reasonable picture to see if there is a possible or feasible relationship. Once you have the scatter plot, you would pick any blue point, you would right-click, and you would say Insert Trend Line or Add Trend Line. If we do that, it'll show you the line that it thinks best fits through this data. And then you can use that line to see if you think there's an association. Now, we are doing linear regression, so you'll see that it highlights the word linear. And there's two other pieces that we're often interested in. We're interested in the equation of the line, so if there is a cause and effect, can I use it to make a prediction? And we're also interested in the correlation and coefficient of determination. So we would click to display that as well. If we do that, they will appear directly on our visual here. So now we have a scatter plot. Within our scatter plot, we have our x-axis being advertising, we have our y-axis being sales, and then we have an equation of the line and an r-squared. So I'm going to start with the equation of the line, and I hope that you have all seen an equation of a line before. An equation of a line is generally written as y equals mx plus b. And so in this case, they're telling us that the value y is equal to 1.2448x plus 105.19. I'm going to talk about the definition of those in a future video. The other piece of information they give us is r squared. R squared is known as the coefficient of determination. Let's make this a little bit bigger and bold. So R squared is known as the coefficient of determination, and it's a really important value that is going to be used throughout almost half of the things that we cover in this class. So it's called the coefficient of determination, but we probably won't call it that very often. We usually call it R squared. And the definition of R squared, the important thing we want to know about R squared is the sentence that he makes. R squared is the percent of the variation in Y that can be explained by X. Okay, so regardless of what type of data we're looking at, it's telling us what percent of the variability in the Y variable can be explained by the X variable. In this case, our Y variable is sales and our X variable is advertising. And what this is telling me is 33%, because that's the R squared, 0.33, 33% of the variation in sales can be explained by advertising. That's not perfect, but it's telling you that some of the variability is being captured, that that basically this line goes through and 33% of the points are pretty close to it or accurately described by it. Okay. The second variable that goes with the correlation of determination, which is as important and related to it, is the R variable. So how do we get from R squared to R? Well, they're directly related. It's the same variable. To get from R squared to R, we take the square root of R squared. Okay. Why? Because that's how you would get to it. It should be R in a second. So I'm not doing subscripts. I'm just going to do this. All right. So R is the square root of R squared. So it's just important that we know that's where it's coming from because they are directly related to one another. But R is known as the correlation coefficient. And it's probably the more common term you'll hear people talk about when they're dealing with a data set. The correlation coefficient tells you the strength, direction, and if a relationship exists between the variables. Now, association is probably better than the word relationship. So it tells us the strength, the direction, and if instead of relationship, let's say an association exists between the two variables. And so in order to determine it, when we're trying to figure out what's happening with R, we treat it like a test grade. And so when we're talking about correlation, now first of all, our coefficient of determination gave us 33% of the variability could be explained. So for this specific model, we would say R is equal to the square root of 0.33. And so if we calculate that, the R value that we're going to come up with, the square root of 0.33, equals square root of 0.33, is going to give us 0.5744. That's actually a kind of correlation. It's not great, but it's got 0.5744. So how do we determine if correlation is good? How do we determine if it's strong? How do we determine if that association exists? There's some specific values you should kind of get used to. So correlations that'll be output and how good the relationship is. Just make these a little bit bigger and bolder. So when we're talking about correlation and we're talking about how good the relationship is, I generally treat it as a test grade. And so as far as the test grade is concerned, if we get a test grade between 90 and 100, so between 0.9 and 100, how did you do on a test? If you got between 90 and 100, how good was your grade? Okay, it was great. In case there's a great evidence of an association. On the other hand, what if you score between an 80 and a 90? Okay, well, if 90 to 100 is great or awesome, 80, because it's an A, 80 and 90 is a B, so we'd say it's a good relationship or a good association. So it's feasible that there's really a relationship here. How about if we score between a 70 and an 80? Okay, we would say there's an okay relationship. It's a C. Some people would be proud of a C. Some people would probably like cry tears and come see my office 27 hours of the week. But it is an okay relationship. There is implying, or an okay association, implying that there is the possibility of something going on between the two variables. And not that I could spell association because there's not evidence of that. All right. What about if our grade is between 60 and 70? Okay. D for done, baby. I would think that student maybe didn't make class very often, was very into playing their video games, and maybe, enjoyed other activities more than they enjoyed studying. But they would get through the class, and so what we would call it is weak but feasible, that there's an association between these. On the other hand, if you score something less than a 60, if you score lower than a 60, you don't pass, in which case there's no relationship. Looking at our data set here, we were talking about advertising and sales. For our advertising and sales, we got a R-squared of 0.33, which gave us a correlation of 0.57. So 0.57 will be just below 60. So really, we'd say that while the line could fit through the data, it's possible that there's no relationship here.